text message that an emergency came up?
She didn't. I didn't get anything. So,
I just got a message from her that an emergency came up, so she wasn't going to be able to make it.
oh,
So,
God, I hope everything's okay.
yeah.
All right, let's start this thing. In a pie chart, why are the slices different sizes? Pie charts are more visually appealing. The slices are different sizes. I would say that's B. Each slice represents a category, and the area of each slice represents a proportion of the total occupied by the category.
Yep, that's what I put as well.
Okay. Okay. How are bar charts and, is that how you say that?
Pareto?
Pareto charts
That's
related?
how I say it, but I might be wrong.
So isn't it just the last one? Because Paretos are in order, aren't they?
Yep, that's it.
Okay. We conclude that, I don't know what that's called, is normally distributed if.
I don't know what that's called either. I mean, it can.
Oh, the true proportion. Oh, no, it's asking, is P the true proportion or the sample proportion?
Oh.
Wouldn't it be the sample proportion because you're looking at N, which is the sample?
I actually wasn't positive on that answer, but that sounds pretty good to me.
Let me pull up.
The sample proportion P is normally distributed if N is large.
But in that equation, I think it's asking P represents the sample proportion.
Yeah, I think.
In P, you've got sample, which is
Oh,
N,
yeah.
right?
Yeah, right. I think so.
Okay. What is N? The sample size.
Yep, that's what I put.
If the proportion is 1/4, what is the smallest N that satisfies the requirement?
This is where I'm at right now.
So if P is 1/4 and 1 minus 1/4
Oh,
is
yeah.
what?
1 is 3
3/4?
quarters.
Okay. So then you have N times 3/4 is greater than or equal to 10. Wouldn't you just divide both by 3/4? So 10 divided by 3/4?
0.75.
Isn't that right?
Yeah. I don't remember looking at this, honestly. I was confused by the question.
13.33.
That's what I got. Does it tell you to round?
It doesn't.
Which almost makes me think the answer is going to be a whole number.
So what's the smallest N that satisfies the requirement? So hold on, because that.
Where is this? What's the smallest N that satisfies the requirement?
Let me open that back up.
Just open it up. Let me see if I can remember where it talked about it.
Come on. My computer is running so slow these days.
P is 1/4. What is the smallest? So wait, would the answer just be 4? Because our P, our proportion, would be saying that we got a result 1 out of 4 times, isn't it?
The equation. Sorry, I don't remember what the equation is, so I'm looking just to see if I see it.
Yeah.
Coin is tossed 25 times, but that's if we know what it is. So if we know the true proportion of people who support particular. Oh, and it says P is the true proportion. So we'll need to change that one.
Oh, is it?
Because
Okay.
P with the little hat
Yeah. Is the sample?
is the sample proportion. P with the little hat is normally distributed if n is large. The true proportion mean of the random variable.
Okay. So the
So
P.
I didn't go back and look. What is it? Is it the P? So is P the true proportion or the sample proportion?
Yeah.
So
And P is the true
P
proportion?
is the true proportion.
Yeah. Okay. What is the mean of P?
Wait, so hold on. Did we figure out number 7?
My guess is 4. If you're wanting to keep a look at it, then you can, because my answer is a guess. I'm not confident with it, but I think it's 4. Because I think proportion is how many times you got that result. So it'd be saying like on a 4-sided dice, basically, you got one time. And so for something to be 1/4, you couldn't have 2, you couldn't have 3, but if you had 4
So that would be the smallest.
yeah, I think it's 4.
I see. Okay. Okay, use the following information to answer questions. Suppose your sample mean or your sample size is 24 and your proportion is 0.04, white 0.4. Okay, so that equation,
So we can't use central limit theorem because the mean of P hat equals P if there is enough numbers. But if there's not, we have to calculate it.
right.
Where is that calculation?
I still can't find it.
Yeah, all I see about the mean is that the mean equals the standard. I mean, they're the same if your thing's big enough. I see how to do the standard deviation though.
Right.
Or we might as well do that real quick, just because you found it as well. Deviation is Divided by.
Okay, so, well, no, that's a standard deviation.
It doesn't tell us to round on the standard deviation, though, now, either. I'm
Is
upset
that what
about it.
we're finding, or is that the next one? I didn't read past. That's what
I'm
the next
The next one's standard deviation, so just since I found that equation a few times, I figured I'd run it through my calculator. But now I'm back to trying to figure out, did you figure out how to figure out the mean?
Mm-mm. No, because all the other ones, the mean is given.
Yeah. Summary. And for it to be sufficiently large, it has to be 30 numbers, right?
Yeah, 30 or more.
So 24, it wouldn't be, we couldn't conclude that it was standard.
Okay, hold on. Darn it. Oh, we can't find a equation on how to find something.
I'm looking it up right now on other things, but everywhere it just says, oh, well, it's P. Because,
That's what I did.
yeah, everything says the
Googled
same
it.
thing. I like how the name of that P with a little hat is called P hat.
Oh my gosh. What else was? Next, the number of individuals with certain characteristics. So, hold on, I'm going to play a video, so if you hear something, sorry, let me mute it.
No, I mean, you can play it if you want, that's fine.
A lot of times, he runs right through things, but I don't remember seeing that.
Yeah, me neither. I feel like, why are we ever doing a test where the sample mean isn't big enough to be normally distributed?
Probability for. Okay, let's see. So p hat is the number of individuals or whatever we're trying to find divided by the sample size. So that's how you find the sample proportion.
Okay.
But we don't know the sample proportion. Can we find the sample proportion using that equation first, you think?
I don't think so.
Let's see. This says distribution of the mean. Mean of the sample mean. You already know what that is. Standard deviation. Okay, but how do you find that?
Oh, wait.
Did you find it?
I think there's a new rule on our standard distribution.
Like, that's all we have to plug in? No, wait.
Because under 3.2-1, I mean 3.2.1,
Yeah.
it says how large is large enough. And it's got a new rule. It's not just 30 anymore.
Okay.
You can conclude that there are the effects of these two conditions. If oh wait, that if P is very close to 0 or 1, then P hat isn't close to the normal unless N is very large. So N, but where it has NP, it's just our N times our P, and that's definitely not greater than or equal to 10, I'm afraid. If
24 times 0.4?
Yeah, it's really low. 24 times 0.4.
Well, it's 9.6.
But it's not greater than 10.
No.
So it's not big enough. So that puts us back to the, it's not large enough. It's close. It's almost normally distributed.
Let me see. Okay, that's given us the mean. That's given us the mean.
It never says, after that it's always like, so if it's good, then you're good. It never says, but if it's not, this is what you do.
So did we, I mean, is the mean of P hat just going to be the 24 times the 0.4? So the 9.6?
No.
You don't think so?
No, I don't think so. Because our mean, I mean, if it was normally distributed, our mean would be 0.4. Because P hat, the mean of P hat equals P when it's normally distributed. So since we're really close to being normally distributed, it's going to be really close to 0.4. So I think 9.6 will be way too far. I think the answer is going to be anywhere from like 0.1 to 0.7. And it might very easily be 0.4, but we can't, I don't think we can just say it is. We can't just determine it to be 0.4.
Oh my gosh, I really don't know.
Yeah, I think I might just put 0.4 because that's everything that it teaches us says Oh, the mean of p hat is p. It never, as far as I can tell, it never says anything otherwise. It never teaches another way to do it. So I'm expecting to get it wrong, but at the same time I don't know why, because I don't feel like I was taught the right way.
The proportion of people who support a particular and what are the mean and standard deviation and shape of the distributed? Okay, hold on. So it talks about if the true proportion, this is a different question, but it says if the true proportion of support who support a particular political candidate is P equals 0.48 and N equals 1041, what are the mean and standard deviation in shape of the distribution of samples? So P would equal 48%, basically. And then you would take that, so you would do the square root of P, which is in our case 0.4, and times that by 1 minus 0.4.
Yeah.
Divided by N, which is 24. So what do we get then? Let's see. 0.4 times 1 times 1 minus 0.4 divided by 24, and the square root of that is 0.0316, so 0.032, or basically 3%.
0.03?
Yes.
What you just did, though, isn't that what you have to do to get a standard deviation of p hat?
Well, but see, so that's what I think. So I think that might be our standard deviation, because on this it's showing that the mean of the sample proportion is equal to the proportion, which is equal to the 0.48 in this sample. So it would be equal to the 0.4. And then our standard deviation would be that other one. So I think you're right.
I did get a different answer, though, when I was trying to get the standard deviation, because since I knew how to get it, I just decided, so let me try mine again real quick. Because it's 0.4, isn't it? Yeah. So 0.4 times 1 minus 0.4 equals 0.24. And that's divided by N divided by 24. And I take the square root of that. I did get a different answer than what you just said.
Did you get just 0.1?
I got 0.1.
Okay, then let's go with that. I think I did something wrong the last time I did it.
Yeah, well, I did something wrong the first time I did it because I got 0.02. So mine was really close to your first one. So I think we may have made a similar mistake, but not identical. But yeah, I'm definitely getting 0.1 for that.
Okay.
So that's our standard deviation. What are we doing about the mean?
I put that it was 0.4, that it is that it's just as simple as that, is that it is just equal.
Yeah, that's what I put as well, so. Alright, so then the next one. Since I just did I see 11 is the standard deviation, so since I just did that and know how to do it, I'm just going to run it real quick again. 0.31 minus 0.3 equals divided by 1. 3 decimal places.
Mm-hmm. She had an emergency or something. Okay, well, so I'm confused because on the next one, to find the z-score,
On 12?
is that what it is? Yeah.
Yes.
So the equation is p hat minus p over basically the standard deviation
Uh-huh.
of p. How do we, but in this example, it shows that p hat is larger than p, and I don't know where they came up with p hat.
I'm having trouble. I'm on the exact same, because did you skip number 10?
Well, I put that it was 0.3.
Yeah, I considered that, but that is clearly not right. Yeah, based on, I kind of came to the same conclusion. I thought, well, never mind. Because the mean of p hat equals p. Man, for how easy this one started, didn't end easy. Oh. I think it's just 0.35. Because it's p hat. Oh no, because that's the. Fine. Oh wait.
Because in that same example, the political election example,
Mm-hmm.
it talks about finding the z-score, but it says to address this question, we first note that the survey will suggest that the candidate will win if more than 50% of the people are surveyed. So that's how they got the p hat, was that it's 0.5 because it's 50%. But
Yeah.
I don't see anywhere in this question that it talks about anything like that.
I think it's down. Oh.
Brittany's batting average is 0.3. We want to determine the probability that she will get more than 35 hits in her next 100 bats.
The way to do this one is actually it's 331.
Is it 35 divided by 100?
Yes, that's your p hat.
Okay.
I just found that out as well about 5 seconds ago. So
Well,
that's
and as I'm reading it, I'm like, okay, because it really is x over.
X over n.
X over n. So if we go back, what is the mean of p hat?
The mean?
Back to question 8. Would we just leave that one still alone?
Yeah, because we don't have an x for that one.
Well, x is the mean.
What?
All right. Well, I'm just going to leave it because I'm like,
Yeah.
I cannot understand right now.
Yeah, I have no way to answer it other than 0.4. And if it's right, I'm going to be upset. But if it's wrong, I'm going to be more upset. So.
Okay. So 10, we've decided then is going to be 0.35.
10, 0.35. Yes.
Okay. And then 11. Sorry, my computer's frozen again.
That happened to me last week a lot.
Oh. See,
Is it like the BYU part or your computer?
it says, oh, now it went away.
What does it say now?
Do you have a Mac or a PC,
I
Addison?
have a Mac.
Do you? So do I. And it would come up with these errors saying that it wasn't responding and that it needed to kill the apps.
Yeah. That happened to me last week a bunch.
Okay.
But this week, mine's running good, so.
Probably a lot of people on the server. Servers.
Yeah.
They're smoking again. Can you close it?
Yeah, I'm outside of
Okay. Our neighbors smoke in their backyard and it comes into our backyard.
That's nice. My sister lived somewhere like that, and she had it quite often. So I've heard how terrible that can be.
It's just gross because we can't have the windows open and it's nice outside.
Yeah. She lived in Denver. It was the exact same. She lived in an apartment though, and it was the people underneath them would go out to their balcony and smoke. So she just. And I was there once, and it was terrible. Because you're just enjoying your life, windows open, nice breeze, all of a sudden, smoke. So, normal app.
Okay, so the standard deviation is 0.3 times 1 minus 0.3 divided by 100 square root. Did you get 0.046?
0.046. Yep.
Okay, so if that's the case, then the z-score is going to be negative 6.17.
Yep, that's what I got as well.
Or 0.172.
Oh, shoot, I did 171. Good. Oh, no, I did 172. Right in the answer sheet, but I did type it down wrong in my applet.
72. All right, so of course I don't have the applet open like I should always just have the applet open.
Yeah. Did you use the applet on the exam, though?
Not at all.
Neither did I. I'm just making sure, because I'm trying to justify why I got some stuff wrong, and I knew it said use the applet, and I thought, I didn't use the applet. I wonder, maybe that's step one.
I don't remember seeing anything that even had to do with probability.
Yeah, me neither.
All right, z-score was 6.172. And they want to know the probability of what?
It says the probability Brittany gets at least 35 bats. And so if we go back to the 331, it's everything to the... Oh, wait, no. Oh, yeah, it is. Everything to the right is what it's looking for. So to the right of the farthest right one. So just one tail, basically.
Okay, so 6.172. So how do we write this?
You can write it in the standard, in the scientific. You just have to put the E, just like it has in the applet.
3.3716E minus 10.
Mm-hmm. But then it's asking to round to 3 decimals. So it'd be 3.371, no, 372 E.
Okay.
You can kind of check that. Most of the time, if it allows you to put an E, then that means, well, I guess maybe that's not, oh no, they do it differently in theirs. My other classes, if there could be an E, that meant it was in standard, in scientific. But this one, E is allowed in all of them, even if other letters are not. You can write in E.
Oh, that's true. F, R, T are not, but E is.
E is, so yeah. That at least gives you the idea that, well, it's okay, probably. They expected it. So 14 is related to these ones?
If the true proportion of people who support a political candidate, no, so this is going back. So we've got P equals 0.52 and sample of 2,000. We want to determine the probability that the results of the survey will suggest a candidate is losing the election. What is the standard deviation? Okay, so this one's saying that if P hat is 0.5, and that's 0.52. So you would do point.
On the standard deviation, that's just the same of everything we've done earlier, though, isn't it?
Yeah, but instead of using P, we're going to use P hat. P hat is 0.5 instead of the 0.52.
Oh, why are we using P hat?
Because it says, what's the standard deviation of P hat?
Well, doesn't P hat, though? I thought the standard deviation of P hat just equaled that is the same thing we've done the whole time, isn't it?
Well, I think it's going back to, remember when we were doing sample mean minus mean?
Yeah.
So I think it's basically the same thing. It's P hat is not going to be equal to P at all times.
Oh.
P hat is saying right here, it's saying that we'll get less than a 50% of the vote. So I'm guessing that P hat is 0.5.
Oh. Yes. Less than 50, because it'd be, yeah, it'd be 1,999 divided by, wait, no, 999. Because it in it's rounded, that'll be 0.5. Would it be, or would it be 0.5? 0.49 or 0.5? Because it's saying getting less than 50%. I guess that'd technically be 0.49999999. So what did you get for the standard deviation?
I don't know. Hold on.
Then the z-score, oh, would be the value minus mean.
So I got 0.01118.
17? Yeah, but rounded to 3, you'd be 0.11, right?
Yes.
Yeah, that's what I got as well.
Okay. And then, so the z-score would be
Equals divided by our standard deviation of 0.11 equals that. Oh, equals that. So I got a z-score as well. I got negative 1.8.
I got negative 2.727.
What are you doing as your value?
So I was doing 0.5 minus 0.53. Or it's 5.2, not 5.3.
Ooh, that's still different than what I did, though. Because I was considering my value at 0.49. Because it's saying less than 50%, so I consider that to be 0.49.
So doing 0.49, you still came up with the standard deviation of 0.011?
Yes. Maybe that's the reason I was 0.0.
1117, and I was
Yeah.
1118.
Yeah, because I'm actually not 0.49. I'm using 0.4995. Because that is based on less than 50%. So that's saying 999 out of 2,000.
I see.
0.4995. So that's the value I used for where it says value minus mean. So I did 0.4995 minus the 0.5. Because our mean's 0.5, isn't it? Oh no, it's 0.52. Oh no, that's what I did
So it's
though.
still going to come up with the same answer I had before, whether I use your 0.9495 or my 0.5.
Really? Because I guess let me run it again. 0.4995 minus 0.52, right?
Mm-hmm.
What we did. So I get negative 0.205, and then I divide that by our standard deviation of 0.011, right?
Right.
And I'm still getting 1.86.
Okay, 0.495 minus 0.52 equals negative 0.025. Is that what you got?
Mine's zero. I'm doing 0.4995. I feel like that shouldn't make a difference, but apparently it does. Because and that's based off the 999 out of 2,000 is 0.4995.
So then you get negative 1.863 or 864.
Yeah. I can submit first this week since I'm.
No, but I haven't submitted first in a long time. 864. Okay.
Oh yeah, 864.
Probability you compute using the normal probability applet.
Negative 1.864. Where's the probability? What probability do you compute? What?
I don't understand that question.
I don't either. I'm running through. I'm not seeing much. I got nothing to help me. What's the last one?
0.031.
Oh, because it's 0.031 for number 17?
Yeah, what's the probability?
Yeah, how'd you get that?
I put in the z-score of 1.864 and only chose the left side.
Oh, I didn't press enter on my applet yet. Yep, I got the right answer. I got the 0.031. Yeah, isn't that what you said? 0.0?
Mm-hmm.
Yeah. I still had my 0.6 plugged in, so I said my z-score is really, really small. But yeah.
Okay, let's see. I just submitted.
What'd you get?
A 73.
Oh.
Okay. Well, first off, 16, just really quick, 16 is going to be the P, it's going to be the second one. Big Z is less than or equal to little z.
Okay.
The z-score is wrong.
On 15?
Yep.
Dang it. All right. What else was wrong?
Number 13 is wrong.
Really? But is 12 right?
12 is wrong.
No, 12's wrong. So we were doing z-scores wrong somewhere. But standard
And
deviation,
number 7 is wrong. It's not 4.
not 4. Okay, so awesome. So we were doing standard deviation right, and z-scores we were not doing right, it looks like. P hat minus P. But 10 was right?
10 was right.
Seems weird, because that means we should have had all of our numbers. Let me just plug it in real quick. 0.35 minus 0.3 equals 0.05. And what was next after? Oh, so we have 0.05 divided by, and and number 11 is right as well?
Yep.
Divided by 0.046. Wait, how did our z-score end up what it is? What were we doing? I have a completely different answer right now.
So we should have done 0.35 minus 0.3 divided by 0.046. It should have been 1.087.
Yeah, that's what I got. What did we do before?
I have no idea.
All
So
right.
yeah, that would be why our probability is completely off.
Yeah.
So if we do that,
87. So then we plug that in as our thing.
1.087. So then you would get 0.3138 or 139.
Yeah, that's exactly. Do you remember how we decided to get that z-score before?
I have no idea.
Because we weren't even close. I might be going back and watching that to see what we said, but then I might confuse myself.
Right.
Oh, what he's saying sounds smart. These two people know what they're talking about.
Okay, but so how did we not get the z-score correct on number 15?
We probably did whatever.
So I think you should put in what I thought it was.
And what?
0.5 minus 0.52.
5 minus 0.52.
Divided by, what was our standard deviation? 0.011.
Yeah.
So negative 1.818.
Ooh, our answers are a lot closer than I thought, though. So 1.818. Oh, whoops, 8. And then copy that into my applet real quick for a z-score of 0.0345. 0.035. And then I still don't. We did get number 8 right, though?
Yes.
So like I said, I'm a little upset about that. Not really upset, but a little upset. And we got 7 wrong?
Yeah.
So that was kind of my guess, and it was wrong, but I don't have a right answer for it either.
Okay, so you changed 15 to negative 1.818, right?
I did. Mm-hmm. And
then
17 to 0.035.
No, the probability was right.
Oh, 17 was?
Yeah, 0.031 was right.
How did that work out? We got that based off plugging that z-score into the applet.
I know. That's
And what did you type in on your z-score, though? Because does it still show your answer?
818. See, that's not right.
Yeah, if our 17 was right, I feel like 15 had to be right. Does yours still show what your answer was?
Yeah, it was, oops.
1.84, is that what it was? Oh wait, 1.8.
Minus equals divided by negative 1.862. No, 64.
1 point, oh yeah, that's right.
1.864.
4.
Yeah.
That gives us, yeah. So
I don't know.
that doesn't make sense. Did we round wrong? Did you re-plug in the 0.4995?
I did.
0.52, and we didn't round incorrectly? It looks good?
Yeah.
So that divided by 0.011 equals... And 17 you said was 0.031?
Yeah.
I guess I won't round? No. I have to. Because if we plug in that other z-score, we get a different probability.
I know we do.
And so it has to be that z-score, doesn't it? What if we even change it to 0.3? It'll change the z. I guess, will it change our rounding on the z-score? No, it doesn't. It doesn't change how we would round. So, I mean, it could be 0.3 and it could be 0.5, even though... Oh, no, it doesn't change our rounding.
I'm sure the candidate is losing.
6. But if we do the 818, yeah, we already determined that. Yeah. Maybe it's keyed wrong.
$1.818. I don't know.
Yeah, I'm submitting it with the same answer because...
Okay, but 16, I already told you 16, right?
Yes, you did.
Z is less than little z.
Mm-hmm.
What are you going to do on 13?
Which one was 13?
13, oh, well, you got the new answer because...
Yeah, I got a new, like,
was
not even close answer to what we did before.
Okay, so what about 7? If P equals 1/4, what is the smallest n that satisfies the requirement?
7?
So
I don't have a...
Are they just saying what it satisfies the requirement? So if
Oh.
it be a large number,
Yeah, where P is
would
being...
it be 30?
Or where its P is 0.75, our N... So basically it's saying to get to 10, if we're timesing something by 0.75, so if we take like 15...
That's what I did. That's the 9.6, isn't it? Isn't that how I got 9.6?
No, that would be 24.
Oh.
But you can do... if with a P of 0.75, you can be lower, because you can be like 14 times 0.75. Oh, whoops, quit. I know there's a correct way to do this, but I don't know. Doing 0.75. 14's high enough. 13 times 0.75. 13's not high enough, so it might be 14, but let me try it on the other one. 14 times 1 minus 0.75 equals... Ooh, 14's not... Because it doesn't... Oh, there's too much guessing in this one. Maybe it is 30. I'm putting 30. I'm just guessing 30. That's not going to be right. Submit the answer. 7 is not 30, just so you know. And I still got 15 wrong, but we got the rest of them. Yeah, we got those other two right. I don't know what we did on 12 and 13. I fear to watch it because it was probably my fault. Oh. I just got your message. Oh, you're gone. Bye. Oh.
Are you back?
I'm back. Can you hear me now?
I can. I was like, I can't hear you. You're just talking. I can't hear you.
Yep, I scrolled over and saw that message after I'd been talking for like 2 straight minutes. I can't hear you. Ah, shoot.
Okay. So
I submitted.
What did you submit?
Can you hear me?
Yeah.
Okay. I submitted,
Uh-huh.
and I got 7 wrong still.
But everything else was right?
Well, 12 and 13 were right, so we did them right this time. But 15 is still
It's
wrong.
still wrong.
But it's not wrong because 17's right.
I know.
So there might just be like a tiny bit of, what if we did, I'm curious, if we did 0.49 minus 0.52.
I wonder if it's just not a negative.
No, because it's 0.49 minus, so it's going to be a negative at the end.
I know, but
Yeah, that's what I should have tried. I should have tried something different that
Yeah.
still made sense, but I submitted already. Let me see, just give me, what did we divide? Oh yeah, by the standard deviation, divided by 0.011.
right.
Oh, that's way different score though, so that'll give a way different probability. I was trying to just 0.49. I thought maybe it's not as technical as 0.4995.
Yeah,
But-
0.4995 and 5 were giving the same results for the
Yeah,
z-score.
but I went to 0.49, and it's way different answer. Because it'd give your z-score as negative 2.72. So if you plug that into the applet, your probability would be way different.
All right.
But who knows?
Okay. Well, I might attempt the actual homework, not just the group thing, and see before we meet on Thursday.
Yeah. I
I'm
think
just like,
I'll do the homework before Thursday this time too, just to have an idea. Because yeah, since this one we still have a few questions. I mean, I feel like we only have one question actually. That if n is this. I mean, yeah.
how do you find n?
P is a 0.75. What is the smallest n?
Yeah. How do you find n? Yeah. I'll have to go back through and reread and see if maybe I can understand it this time.
You are right. You definitely nailed it on what it's asking. It's saying what gets you that greater than 10 number.
Right.
But as far as like an equation to figure that out without just plugging in a million numbers, I don't know the equation.
See, but I thought it was just if we had p, which was 1/4 or 0.25, and we want to say
0.25. I was doing this at 0.75. 1/4 is 2.5. That was probably when you couldn't hear me. I kept saying 0.75. And that's
yeah, probably.
anymore.
Because I want to say that it's just going to be. See, that still doesn't make sense. That 2.5 is the highest number we need.
On that,
5 times 0.25 equals, no, that's not enough.
yeah, not enough. That one would be 40. 40 for the top one, but what about on the bottom one? You'd have I exited it out, but what's the equation? It's 40 and then times 1, p minus 1, 0.25 minus, did I lose you? Oh no, I didn't.
No.
My computer did a bunch. Remember? The answer might be 40. It could be 40.
Well, because if NP has to equal or be greater than 10, right?
Mm-hmm. So the smallest number on that one would be 40.
So then you would just, if you want to get one apart from each other, wouldn't you just go 10 divided by 0.25?
10 divided by 0.25. Yeah, it would. Yeah, I knew there was an easy way to do it. But what about on the other one? What week are we in? Week 9?
Because then n would just equal 40. So it should have been 40, not 4.
Yeah. What about on you have to satisfy both of those requirements, though. There's the NP, and what's the other one? Let me look at it real quick.
Oh,
The N,
it is.
I just pulled it up. So N times, so it'd be 40 times 1 minus 0.25,
Mm-hmm.
and it has to be, oh, and it's greater than 10 as well. So it's 40. The answer's 40.
Okay.
For sure.
Now we know
Now we know.
how we got it.
Yeah. So we can answer all the questions now, except for the
Yeah.
weird one. But I'm convinced there's a mistake on the answer key.
It's
For that
the
last-
number 15.
Yeah.
Yeah. Maybe I'll ask her to look at it and just let us know, hey, because when can we look at this? Tomorrow, right? At midnight or tomorrow? Okay, maybe I'll just look, and if it's something as simple as that it was just not a negative, but who knows?
Yeah. Oh, do the answers appear
No.
later on?
No, sorry, I was just thinking that the only way to know that is if it'll
We'd
just
have-
tell us it's wrong and we have it wrong, so.
Yeah. We'd have to ask her on the type-in numbers.
Alrighty.
But did you you see that we have another assignment due tonight, right?
Oh, crud. Yes.
But
Final
it's-
project overview.
It's easy if all three of us were here. I feel like we all have to be, oh my gosh. Oh, we're still broadcasting. I'm going to stop this.